And okay. Now, next lesson. The others will just have to catch up. Fian. Sorry to cut into your staring out the window time. Cumulative frequency. Hey, come on, hurry up. I'll explain that now. Well, actually, I'll explain it now. Does anybody know this word from English? Cumulative. No. Pretty close. Yep. So, rough English meaning of cumulative means something that builds up, or as you said, adds up. What words are like this in English that means to build up or to add up? You might have it from chemistry or biology. Very good, accumulate. So it is like this, cumulative frequency. There must be something about adding up. So let's just remind ourselves of a frequency table. Joseph, you are like the noisiest student ever. What?
Did you say nicest?
Yes! Yes, that's exactly what I said. You are the nicest student ever. All right. 0 to 3. 3 to 5. 5 to 7. 7 to 10 as an example. So, yeah, I know. So here, what you've got is frequency table. There are 5 pieces of data which are between 0 and 3. There are 6 pieces which are between 3 and 5. There are 2 pieces between 5 and 7, and then there's 3 pieces between 7 and 10. So if you were to read out this data, it could be something like 2, 2, 2, 2, 2, a number like this 5 times, and then 4, 4, 4, 4, 4, 4, and then maybe 6, 6, and then maybe, let's say, 8, 8, 8 or something, you know. As we saw a frequency table last week. So what's cumulative frequency? So that's this table. And you can make a cumulative frequency table from a frequency table. It's not so difficult. So I'll just write CF here. And once I write in the numbers, you'll see what it is now. Okay. I'll go with okay. I really would like to have less than or equal to here, but, well, okay. If I do it, no, I can't now. It's too late. All right. I really should have less than or equal to. I'll do less than or equal to in the next example, but the idea is the same. So, how much data have we got that's less than 3? Yeah, well, how many numbers are less than 3 here? 5. Because if you think about it, I have 5 numbers which are between 0 and 3. So that means I have 5 numbers which is less than 3.
We have 5 numbers that are between 0 and 3.
Oh, you know what? I'm going to put the equal sign in. I can't cope. All right, now. How many numbers do I have less than or equal to 3? So if you look here,
1,
I'm saying,
2.
no, sorry. Yeah, now I understand the confusion. Sorry. Let me totally rephrase that sentence. How many, I know, I completely understand, I was saying it's so confusing, sorry. How many pieces of data do I have which are less than or equal to 3 in value? So you could have 5 pieces of data which are between 0 and 3. So that means I have 5 pieces of data which are less than or equal to 3. Because after all, do I have any data smaller than 0? I don't, it starts at 0. So I have 5 pieces of data here. Now the next one.
Can't have more.
Yeah, this is just my example. I'm not sure, what are you asking?
No, like more than 5 pieces of the data.
Because the equal sign?
Yeah,
Yeah, you could. So this is why I'm not happy with my example I did first. So let me rephrase this. Stick the word roughly in front of everything I'm going to say. So we roughly have 5 pieces of data less than or equal to 3.
But why did we choose like less or equal to 3?
Oh yeah, where did the 3 come from? Is it? Or why did I use the equals? Okay, yes, okay. Well, firstly, the 3, 5, 7, and 10, they're all the upper bounds there. Okay? I really should not have the equal sign there. Oh. Okay, I'll get rid of it. You win. Whoop, whoop. I could, but it's too late now. Alright. So I have 5 less than 3. Right, so how much data do I have that's less than 5? 11. Why 11? Because I have 6 which are between 3 and 5, and then I also have 5 which are between 0 and 3. So in total, less than 5 is 11. So 11 goes here.
So the other one is 8.
The other one would be 13. Because less than 7, there's 5, 6, and 2 numbers, all less than 7. So they keep adding up as you go across the table. So
It's
how
like
many?
we add like 5 and 6 and then we add 6 and 2.
No, it's not the last 2. It's everything up to that point. So it's 5, 5 plus 6, 5 plus 6 plus 2, and then all of them. So the next numbers would be like this. 11, 13, 16. So that's called cumulative frequency. Less than 3, less than 5, less than 7, less than 10. So I have 5 pieces of data less than 3. I have 11 pieces less than 5. I have 13 pieces less than 7. And I have 16 pieces of data less than 10. So if you think about it, if I said I have 16 pieces of data between 0 and 10, then of course you have 16 pieces of data which is less than 10, because that's everything you have. So this is called the cumulative frequency. It tells you how much you have up to a particular point. So I'm going to do one now where I need to put in the equal sign. But look, that whole equal sign, not equal sign, doesn't really change anything for the graph, which is what I'm trying to get to.
But it changes the CN value.
Yes, but the graph that you draw will be the same. It'll be the same shape. The graph will come in a moment. Let's not worry about the graph yet. Let me do you another one here. Okay, so I'll do 4 again. Okay, so this one here, 1 to 3, 4 to 6, 7 to 9, yeah, 10 to 12. Okay, this one is clearer now. Sorry about that table, it's weird looking. Now, As I was saying earlier, Sarah, the way you get the numbers is it's the upper bounds in each bin. So in the first bin, what's the upper bound?
3.
Is it 3?
4.
3.5.
Good, 3.5. And this in here, you definitely have the equals. 3.5.
When do I know that I should put the equal and don't put it? Like in this example, did you put it in?
This one I did put it in, yeah. You know what? No, I don't know anymore. So I'll go check. Now that I've done it so, you're asking me so many questions now. I feel like I should have it in, but no part of me is feeling like I shouldn't have the equal sign in. Shh. We'll see now. Yeah, he's using Firefox. What a loser, huh? No, we get all our answers now. Oh, come on. There's the table. Oh, here we go. It avoids the question entirely by not writing it in, which is maybe what I should be doing. No, no, no.
Scroll up. Scroll up. There's less than.
Where? Which one?
Less than cumulative. No, up the second one.
Here?
Yeah, less than.
Less than, but no equals, huh?
There is one below. Scroll down. More. Okay. Do you see height of whatever that? Yeah.
Oh no, that's just frequency.
Trust me, follow the same method.
Maybe I'll see.
If you really have to write the less than or greater.
Yeah, that's what I'm thinking now. We'll just completely avoid all of that by not writing that sign in. Yep, that's how we'll do it. So I'll just write 3.5, 6.5, 9.5, 12.5.
Why did you 3.5 instead of 4?
Because it's the upper bounds. Definitely the upper bounds. Definitely the upper bounds.
But like in the previous question, though.
The upper bound was already given, 3, 5, 7, 10.
But if we do this like that, wouldn't this be what? 0 to 3 and 3 to 5?
No, please, please, no. Look, these are the upper bounds because they connect back to back. There's no missing gap. Whereas it must be a 3.5 here where this ends and where this one starts because they're not connected. That's the key difference between them.
But what if we have different numbers?
Like what?
Like 1 and 3 and 11. If they don't connect.
Okay, that would not happen. Yeah. Because then there'd be missing pieces, yeah. So what would I put here? 3. What's next? 4, 7, 9. Okay? So let's do one more example. XF. 0 to 5, 6 to 20, 21 to 50, 51 to 100. So this is the closest I can think of, Sarah, of them. I mean, they still connect, but they're all different lengths, but it doesn't matter anyways. So for the cumulative frequency, we use the upper bounds, which is, what would be the first one here? 5.5, 20.5. This one here would be 50.5, and then 100.5. Oh, and I have to put in my frequencies here. So what would be first? 2, 5, 6, 8.
I'm sorry, what's the UV?
Oh, upper bounds. And then cumulative frequency.
So with 3, so that's less than.
Again, we're going to avoid that question by not writing symbol downs, and we just add up. Yeah. Can I just be clear? I'm deliberately not writing in the less than or less than equal to deliberately not get stuck on that issue. But I will tell you this though, it's always going to be just add up each bin to go into the next bin.
What about in the exact?
Yep.
If we don't want.
No. No. So I was a fool to try and put it into mine. A fool, I tell you. Okay. So anyways, now that we have our cumulative frequency table, what's the application of it? What's the use of it? Okay. Two plus 3 is 5, yes. So I'm going to do this one now just to make it look nice and neat in the table here. So usually would start off in the exam that give you a table. So it could be something like, I think, how many people have a virus or whatever. So sick folk. There we go. Oh no, I know. It was. I think if I think about last year's one, it was how many days people were sick with the flu or some disease or whatever. So 0 to 5 days. That was kind of a bit long, isn't it? 0 to 3 days. Yeah. 4 to 6. 7 to 10. 11 to 14. 15 to 19. 20 to 30, something like that. And then here we have the frequency. So let's say some people were here, most people were here, some people were here, but then you have a couple of people who were sick for quite a long time. Okay. And then we make it look nice and neat for you. Right. All right. Just imagine this is in a nice table. Okay, so you got this here. Now let's calculate the cumulative frequency table. So we have our bounds, our upper bounds. So the first one will be 3.5, 6.5, 10.5, 14.5. And then 30.5. And then we have cumulative frequency.
5.
So that equals the first one here, 5.
11.
And the next one should be 11. And the next one? 16, and so on. Okay? What do you do with this data? Well, you put in something that's called a cumulative frequency curve. How do you draw a cumulative frequency curve? Well, on the x-axis you put these numbers, 3.5. Now you don't need to write this table down. I'm only writing this table so I can draw it in Excel, okay? 3.5, 6.5, 10.5, 14.5, 19.5, 30.5. So what you just need to know is that you draw this on the x and you draw this on the y, and you draw it like a line graph. So that's why we did line graph in the first lesson. You put each point on the graph and then draw straight lines through them. So 5, 11, 16, 19, 21, 22. Okay, scatter, points, next. So this is called a cumulative frequency, I'll just write CF for short, polygon. On the x-axis is the upper bounds, and then on the y-axis is the cumulative frequency.
What is polygon?
Polygon is the name of that graph you get where you go point to point with straight lines. Yes. So that's what it looks like. I'll shrink it down a little bit for you. Okay. There you go. So the only reason I opened the program is to get this nice graph for you. But it looks a lot like a line graph. On the x-axis is the upper bounds, and on the y-axis the cumulative frequency. So I took this data here, wasn't it? No, I made up my own data.
So what do we understand here from the...
Yeah, how do you read it? What way does it work? So the way this graph works, suppose like if you were a doctor and you were given this chart, how do you read it? What does it mean? So you might want to say, okay, the people who got sick, how many people were sick for less than 10 days? So you go, okay, 10 days, that was 15 people were sick for less than 10 days. And you might say, okay, 30 days, how many people were sick for 30 days? So that's about 20-something people. But the reason you draw this graph is because now you can pick numbers which weren't in your data. So like for example, I could say, okay, how many people would be sick for less than a week? So if I had, well, how long is a week? How many days? 7. So I can go, here's 7. So that's about 13. So I can say, okay, 13 people were sick for less than a week. So that's how you can read this table here, cumulative frequency table. Okay. But why is it useful apart from that? Well, the other thing you need to know about the cumulative frequency table is how you can calculate the median from it. So you remember last time we calculated the median by putting it in order and taking the middle one. Well, you can actually get that from the cumulative frequency curve as well. So what's the biggest point there on the y-axis? It looks like 21, 22. So what's half of 22? 11. So what you do is you go from 11, you go across and you go down, and this number here is the median. Okay? I don't think I can draw that in on this graph, so I'd like you to draw that in. So what I need you to do now is copy down the table, then the graph, and then we'll talk about putting in the lines. So I'll go back up to the... maybe I'll make this a bit smaller here. There we go. And if I delete this here... Okay. Whoops, uh-oh. All right. So these two here was given in the question. We found the cumulative frequency table and then we drew its polygon there. Paint. Well, I'll let you copy that first down. I'll do it in Paint. Now, I'm going to tell you something good for you. Of the last 12 exams that I have, this has come up 11 out of 12 times as question 6 in section B. Okay, so what they do is, part 1 is they give you a frequency table. Part 2 is they ask for the cumulative frequency table. Part 3 is they ask for the graph. Part 4 is they ask for the median and interquartiles from the graph. And then the last part, part 6, which is the only really difficult part, is they ask you to calculate the standard deviation from the frequency table. Yes. Do you have a copy of the papers with you? The book I gave you. So if you look here. See? They give you a frequency table, and then the first one they ask for the average, so you multiply it all. And standard deviation is something similar, so that's 9 marks. And then they ask you to draw the cumulative frequency table beside it, that's another 4, and then put that on the graph as well. And then the last part is get the median from the graph, which is 2 marks. So you see, this is nice.
It's the first question I want to answer.
First one you won't or will?
No.
Good, yes. And it's the first one everybody, in the exam, it's the first one everybody should do when they start section B, is the last question, which is the statistics. Do you have those numbers taken down? I'll put the graph up in a bigger screen now, actually. Okay. Right, so there it is there. You got the numbers? Yep. I'm going to put the graph in a separate window. Okay. Come on. Edit. Copy. Do I have to export it first, is it? Export. There we go. Okay, so there's the cumulative frequency graph, the bounds on the x-axis, the cumulative frequency there. So how do you get the median? Well, the biggest value is 22, so what you do is you go to half that on the y-axis, which would be 11, so that'd be about there. And then you go across to your graph, and then you go straight down. So this number here, which is, what we say, about 7, that's the median. So the median is 7. So half the people will be sick for 7 or less days, and the other half about 7 or more days. The median is the middle value. Okay, so how do you think I get the lower quartile? Well, it'll just be half of this again. So in blue here, that would be around about here. So what's that going to be? Around about 4.
Half the lower.
Yep. With the, by the way, with the cumulative frequency graph, you don't have to do anything about or round up if it's even or round up if it's odd or anything like that. You just take the half number, and because you have decimals on the y-axis, you can go to 5.5. You don't need to round it down to 5 or up to 6 or anything like that. Okay, so what would be the middle here of 11 and 22? So that'd be 11 plus 22, which is 33 over 2. Yeah, 16.5. So 16.5 be around about here. Whoops. Oh, so what's that, about 12? When you do this on graph paper, it'll be easier to see.
What's 12?
So that'll be the upper quartile. This is the lower quartile, and then this is the median. The only difference is where you start on the y-axis. Yeah?
Oh my god, the median is seeing like the bigger value and divided by 2.
Exactly right, yeah.
And the other?
The upper would just be 3/4 multiplied the bigger value, and then the lower would be 1/4 multiplied the biggest value. So 3/4 multiplied by 22, I hope, is 16.5, and then 1/4 multiplied 22 is.
Why did you choose like 1/4?
Oh, because lower quartile. If you remember, it's the middle of the lower half, so that means 1/4. And then the upper quartile is the middle of the upper half, so that's 3/4. So I'll put a little note there. This one here is at 3/4 the maximum. This one here is at half the maximum. And then this one here is at 1/4 the maximum.
What's the number below?
Below which one?
12.
Below the 12.
No.
What? Here?
Half. I got the number.
Right, okay. I'll zoom out a bit. Or maybe... Can you, like, will I zoom out so you can see it? Can you still see that? Yeah. Oh yeah, and then lastly, what's the interquartile range here? Yeah, 12 minus 4, so 8 then.
Sorry, I didn't understand.
The last point, interquartile range. If you remembered when we did our quartiles, the formula is upper minus lower. Yep. So 12 minus 4 here. So can you listen, please? Hey, listen. Look up. So I've given you 6 questions here. In the first 2, I've already given you the cumulative frequency table. So you just go straight into drawing the graph. In the second one, I give you the frequency table. So you have to go into making the cumulative frequency table. And in the last one, I give you the data. And you have to put the data into a frequency table, put the frequency table into cumulative frequency, and then put it into the graph. So, short, medium, long. In the exam, they give you number 3 or number 4, where they give you the frequency table and ask for the cumulative frequency table and then the cumulative frequency graph. Okay? Like I said, that has come up 11 out of 12 of the last exams. And when it hasn't come up, all they asked for instead of a cumulative frequency was they asked for a histogram. A histogram is something you did in biology and chemistry, which we'll do next time. So either way, it's going to be cumulative frequency or histogram. And you delete all those less than or equal to's in the worksheet as well. You can scratch them all out. Can I close that graph? Yes.
frequency polygon is just another way of saying that.
Yep.
Sorry, in the next project, when we state Newton's law, should we like add reference?
Yes, but I mean, it's just going to be like a website or a book or something where you got it from. But yes, I would like. Probably going to have just a couple of references in it, right? So yeah, I would, yeah.
So it's not supposed to be so academic.
What other word?
What do you mean by so academic?
Like, it's okay for them to have an author name just from like a regular website.
Yeah, but at least make sure the website looks pretty academic. Like, if it would be great. It'd be great if you could get like some notes from a school website or even from a book online. Would actually be best. Yeah, don't copy it from a blog or something like this or someone's tweet or whatever. Yes.
Who's going to tweet?
Yes, that's right. Who's going to tweet about that? You never know. There's weirdos out there.
We also have to
Yeah, but like what like I mean, ideal gas law is something I think a bit too general, elementary to be referenced, you know. What else is there? No, see, there's not many actual equations apart from just, you know, the regular kind of getting the average equations, you know.
How about the volume of that? So
Yeah, like it's just, I mean, I don't even think you could find who first discovered that, you know.